Welcome back to Smitty's Learning Room. Today we're going to have a look at the last section of the Body in Motion syllabus, and we're going to start by looking at motion. Before we start, we need to have a look at biomechanics and understand that biomechanics is the science concerned with the forces and the effect of forces on and within the human body. Biomechanics is an important area for both athletes and coaches to understand in relation to sport, because it allows us to improve movement efficiency, which will allow for greater results and decrease the risk of injury. It also allows for the improvement of technology and the design and use of equipment that sports people use. Let's start by having a look at the concept of motion, and motion is the movement of the body from one position to another. There are different types of motion, but the main one that we're going to focus on is linear motion. Some other aspects of motion that we're going to explore today is velocity, speed, acceleration, and momentum. Having a look at linear motion takes place when a body and all parts connected to that body travel in the same distance in the same direction at the same speed. So for example, if we have a look at our swimmer here, you can see that the main parts of the body are all travelling and working together at generally the same speed and direction to move forward. Another example of linear motion is a skier moving straight down the hill. So an athlete, or the body of a person that is moving from one place to another with all the parts moving in exactly the same direction at the same time, is considered linear motion. When we're looking at athletes who are moving from place to place that isn't in the same line, that's when we explore the concept of non-linear motion. In order to understand linear motion or motion a little bit better, we need to have a look at some of the principles which can affect motion. The first one we have a look at is velocity, and velocity is equal to the displacement divided by time. To understand how velocity works, we need to understand that displacement is the movement of the body from one location to another in a particular direction, or as the crow flies. So for example, if we look at this picture here, this is a displacement from the start to the finish as the crow flies, but the actual race is non-linear and the direction is changing. This is why we need to look at the concept of velocity. So for example, a cross-country runner, or even the flight of a javelin path, both have differences of an incline or decline. And activities which require the improvement of speed may also relate to velocity. So improving the velocity of implements such as javelins or the velocity of a cross-country athlete improves the performance of athletes in non-linear events such as marathons. So in summary, when we look at the concept of velocity, it's basically speed with direction in it. So we're changing direction and we're not just going in one direction. When an object moves along from one place to another, we often refer how fast that object is moving, and this is called speed. Speed is equal to the distance covered divided by the time taken to cover the distance. So for example, if a runner covers a 100-metre sprint in 12 seconds, the speed is determined by dividing the 100 metres distance by the time. So 100 divided by 12 equals 8.3 metres per second. Speed is obviously a very important factor to take into play for athletes of any sport. Speed, or much of our potential for speed, is often quite genetic and relates to the type of muscle fibres that we have in our bodies. However, individuals can develop their speed as a result of training and techniques improvements, and this is where the science of biomechanics comes in handy to actually be able to analyse athletes' movements and technique to try and improve their speed. Acceleration is the rate at which velocity changes in a given amount of time. So for example, a powerful athlete or a powerful sprinter is able to increase speed quickly, and this is called acceleration. A sprinter aims to develop a technique which enables maximum acceleration. This requires a lot of training and often power training implemented into their training program. When exploring acceleration, we also need to explore velocity. When an object or a person is stationary, their velocity is zero, and their increase in velocity increases as they accelerate faster. And obviously there's a decrease in velocity as they decelerate or slow down. For example, a sprinter before they start the race would have zero velocity. As the gun goes, their velocity would increase and continue to increase over the 100 metres. Obviously, once they cross the finish line, their velocity would decrease as they start to get slower. Like speed, acceleration is a skill that's highly valued not only in sprinting, but in many individual and team sports. The ability to accelerate depends largely on the speed of muscular contraction, but also the use of certain biomechanical techniques such as forward body lean can significantly improve performance of the skill. So coaches obviously have a look at measuring an athlete's acceleration capacity by viewing videos and assessing how much lean the body may need to increase their acceleration rates. Momentum refers to the quantity of motion that a body possesses. The term momentum is commonly used in sport, and often we hear it, for example, in the games of rugby union or rugby league. When we look at momentum as a product of mass and velocity. So mass obviously referring to the amount of matter in the body. So, for example, a front rower's weight. And momentum is expressed as momentum equals the mass times the velocity. When we look at momentum in sports, we look at the concept that, say, a 50-kilo rugby player versus a 100-kilo rugby player travelling at the same speed. Which one would have the most impact when taking a tackle? Obviously, the 100-kilo rugby player is going to have more of an impact because they've got more momentum going at the same speed. This is why we often see the weights of scrum packs displayed in rugby, because obviously the heavier the scrum pack, the more momentum the scrum has once it starts to get moving, and therefore the more powerful it will be. The momentum used to, say, take a tackle in rugby league or to pack a scrum is what we call linear momentum. We can also explore the concept of angular momentum, and it's the quantity of angular motion in a body or part of a body. One of the best examples for this one is actually a discus thrower. There are many other sports which use angular momentum, such as performing a somersault in a dive, tennis serving, football kicks, and a golf swing. And in each of these sports, the body or part of it has to manipulate some kind of object, and therefore we call it angular momentum. When we look at angular momentum, coaches and athletes obviously need to explore these concepts to try and improve or increase the capacity of the object that they're manipulating. Angular momentum is affected by three things: angular velocity, the mass of the object, and the location of the mass of the object in respect to the axis of rotation. So obviously, for example, when we're looking at angular velocity, the distance we can hit a golf ball is determined by the speed at which we can move the club head. So the faster we move the golf club, the further the ball goes. The mass of the object, so the greater the mass of an object, the more effort we need to use to increase the angular velocity. So for example, it's much easier to throw a smaller discus than what it is to throw a larger discus. But if we want to put more speed behind the throw of the larger discus, it will actually go further. The location of the mass in respect to the axis of rotation. With most sporting equipment, the centre mass is located at a point where the player is able to have control and impart considerable speed. Therefore, the centre of the mass is well down the shaft in most pieces of equipment, so it enables the player to deliver force by combining the mass of the implement at a speed in a controlled manner. For example, when you have a look at a cricket bat or a baseball bat, you'll notice that in the centre of the bat, it tends to widen out in the cricket bat, and therefore allowing more strength for the player to actually maximise the ball being hit in that section, allowing it to be hit further.